Hello, good afternoon, and welcome back to Music 110, Introduction to Audio Technology. Today's lecture will be on the digital audio workstation, an introduction to it. I'll be talking about the digital audio workstation, and then we're going to dig into Studio One as one example of a digital audio workstation. This will be the music audio application that we'll be using for the rest of the semester. So today we'll learn about what the digital audio workstation is, and also be introduced to Studio One, the particular version of the digital audio workstation we're going to be working in. So the digital audio workstation, also known as a DAW, I'll often be referring to it simply as a DAW, is a software application that we use to manage audio, MIDI, and do all of to manage the encoding of audio into sound files. You can think of the digital audio workstation as a digital representation of a recording studio. So here I have a image of a control room in a recording studio. So when I say control room, you'll notice over to the left there's a window. And if you look really closely, you might be able to tell that there is, over here, a microphone stand sort of through this window over to the left. So that is the recording room, the sound room. Here, separated from that room, is the control room. This is where the audio engineer does all of the mixing and all of the recording and all of the monitoring. So you can see here there's a chair in front of a desk, and the desk has this mixer on it that has many channels. So that's what I'm looking at here. There we go. So here is this large analog mixer. All of the recording that goes on in this room over here, in the recording room, is sent through cables. So if I'm singing over here in this room and you are recording me in the control room, I will sing into a microphone that will go along a cable that is plugged into the wall. It will then reemerge on this side, and all of these cables from all of the different mics and inserts that we have in the recording room will be inserted to the back of this mixer so that each mic gets its own channel. Now, we can see a lot of other things that are going on in this control room. So you have the mixer, and all of the sounds that are happening in the recording room are coming into the mixer. They're all being put together and brought into the computer itself, where we're able to manage all of those different inputs and put them together into one stereo sound. Why do I say stereo? Because I can see right here that really there are only two monitors, only two speakers. It could be that they have some other speakers set up in this control room to do surround sound. But from what we can tell from this, there are two speakers. This is like a very standard setup, stereo sound. So if we are recording, say, a large jazz band, like a 12-piece jazz band, so we've got a mic on everyone. We've probably got at least 4 mics on the drum player, maybe more. We've got some room mics to pick up the sound of the entire room. So, we've got upwards of 24 plus microphones that are all coming in here, and all of those individual microphones eventually are going to be put together into a stereo track, 2 waveforms. So that's all done in the computer and then written out to disk. There are a couple of other things that are going on in this control room. Over to the left here, we see some analog gear. This is a reel-to-reel tape recorder. So this would be, you'd be using this if you wanted to be recording to tape. We also see over to the right here, this whole wall. It almost looks like, like an old science fiction spaceship movie or something with all of these buttons and knobs. These are all effects. So when I say effects, it's ways that whatever sound is happening over in the recording room, that sound, that signal, it goes through the microphone cable, can be sent through some sort of process that is going to change that waveform. That process could be amplifying it, so making the waveform, the peaks and the valleys of the waveform increase in height, so to speak. It could be we're adding echoes, so adding artificial reverberation. It could be we're adding distortion to it, which we'll learn about how that works. It could be some other type. We could be filtering it, taking out the low sounds, taking out the low part of the sound, taking out the high part of the sound. There are all sorts of effects that we use to process the waveform, to change the waveform for all sorts of different aesthetic purposes. So we have effects over here. Essentially, how to think about these effects is the sound comes in from where you're recording. In this case, it's in an actual recording studio. In your case, it will be either a sound that you recorded on your phone or a sound that you found somewhere online. That sound then enters into your recording system. So here, that sound comes in. We can play it back through some effects. So the sound goes out, goes through whatever effects we have on, it comes back in, and then we hear it having been processed. All of that then eventually is summed, is brought together into the master mix, which is just a stereo signal, two waveforms, left and right. So all of that happens in the analog recording studio, and the digital audio workstation is a digital representation of all of that. So when we open up the digital audio workstation, you'll see, oh, this is like a mixer. I have a fader that lets me to make one track quieter or more loud. I have a knob that allows me to move it from left to right. Here I can add effects. Essentially, that's like sending this track through some effects and then back into itself. Okay, so what does a digital audio workstation actually do? So it lets us multi-track record, edit, and mix down, which is just like a sort of expensive traditional recording studio. It allows for MIDI sequencing, editing, and scoring. In other words, MIDI, which is a language, a programming language that allows different digital instruments to talk to one another. You can edit all of the musical information that is going back and forth between these instruments. You can sync with video. You can integrate all sorts of hardware to the digital audio workstation. So just because it's on your computer doesn't mean that you can't augment it with other machines. So in other words, you could have Studio One on your computer, and you can hook up Studio One to some hardware, to some analog gear, and the analog gear can be controlled from Studio One. Again, so we've got plug-in DSP support, so digital signal processing. That is the digital version of these effects that I was just talking about: echoes, distortions, filters. Plug-in support for virtual instruments, which is really what we'll learn a lot more about this when we dig into MIDI. But what this is just digital representations of various keyboards, all sorts of instruments that you can then manipulate. And you get support for timing and control with other software. So the digital audio workstation you can think of as something that you can use to edit and to compose with, But it's like your command central, and it's a way that you can connect to and integrate other applications and other musical hardware, other instruments, other effects and devices. So why is the digital audio workstation so advantageous, and what does it allow for? What are its affordances in comparison with the analog recording studio? The digital audio workstation, it integrates. So, like I said, you think of it as like command central. It's centralized control over recording, editing, processing, and signal routing of audio. You can do it all from one place. As opposed to if you think back to the picture of the analog recording studio that we just had, I mean, a lot of that has a lot of it is like physically unplugging cables, plugging them in, making sure all of the connections are going to the right place. Here, it's all automated and it's all digital. All of your connections are happening within the computer and are really just all you do is sort of click the connection. And you get direct communication with hardware. It allows for communication. So it distributes audio, MIDI, automation, digital timing, sync throughout a networked system. So when you all are working in this class, it's mostly going to be pretty much self-contained to the computer that you're working on. However, as you continue to work with digital audio workstations, you'll find that it's actually very easy to expand the system and use the DAW to communicate with different controllers, different effects, all of that. Also, if you're doing some sound with video or sound with film, it's also it will be your command central, and we'll learn about why in just a second. Once you're familiar, it's much more faster to work with than with analog gear. Like I just said, you're really just kind of clicking through a bunch of different windows that are organizing so many different connections. So when we were looking at the analog recording studio, and I was saying, well, let's imagine like a medium-sized jazz ensemble. You've got at least 24 mics. I mean, that's 24 individual connections that you're connecting, then reconnecting at different points, right? You have to plug them into the wall, then you have to plug them into the mixer, then you have to plug them into the effects, all of that. This brings all down, it gets rid of a lot of those physical connections and allows for a lot more flexibility and obviously speed. The DAW also allows, and this is really, really important here, it allows for saving, recalling, and editing performance information. And when I say performance information in this context, I mean like fades. So, for instance, if you wanted a fader to slowly bring in the sound of an organ sort of droning, if you wanted that fader to slowly bring it into the texture of the music, you can, with the digital audio workstation, you can record yourself bringing that fader up just at the right speed. You can also draw that shape of that fade. You can edit that shape of that fade. And this type of automation, this type of changing parameters as time progresses is really unique to the digital audio workstation in comparison with the analog recording studio. And I mean, I think I've been hinting at this the whole time. The DAW is completely expandable. It's designed so that it can talk with all sorts of different protocols and all sorts of different technologies. And so once you learn it, you can start expanding it and getting different DAWs to talk to one another. There are all sorts of ways to expand and integrate other types of musical tools. Okay, so this takes us. So here, what we're looking at right now is an example of a DAW. This is Studio One. Already, you can see how just the visual representation that you see on your computer screen relates very directly to the analog recording studio that we were looking at a second ago. We have the waveforms here, which you could think of as, when we were seeing that analog tape, you could think of this as a strip of tape that is just laid out flat on a table. Okay? So, and next week, when we really dig into different splicing techniques, that analogy between the track in the DAW and thinking of it as analog tape just laid out on the floor or laid out on a desk will be really useful. So here we have all of the tracks, the waveforms, or you could think of them as sections of tape laid out in tracks. You can have as many tracks as you want. You can have stereo tracks. You can have mono tracks. A mono track is just one waveform that gets sent equally to the left and the right channel. A stereo track is two waveforms, one that goes to the left and one that goes to the right. So you can have mono tracks, you can have stereo tracks of audio here. These tracks, whatever is playing here, when we open up the mixing console, each track will have its own set of controls with a fader, mutes, panning, all sorts of ways that you can change it. All of these then get sent over to our main master mix, which is all of these different tracks summed into a stereo track, and that's what we hear. We hear the output of the main. Time is going from left to right. So here we see this line that we see going down across all of these tracks. I will be referring to as the tape head. And the tape head is going along this ruler, which is indicating a progression of time. So here, we have the mixing board, right? We have our tape, our recordings. This is the master of the mixing board, so this is what outputs to our speakers. We'll find our effects over here, and we can add them to tracks from this window over here to the right. So in a lot of ways, this is very similar to an analog recording studio. But what's different about the digital audio workstation is going back to how we were defining the difference between analog and digital, being that analog is continuous time and continuous change in amplitude, and digital being discrete change in time and discrete change in amplitude. So now, in the case of the digital audio workstation, something that it's one of its main functions is to integrate multiple devices, some of them analog and some of them digital, together, is that no matter what, there will always be what we call latency, or a short delay between when the information gets to the computer and when it gets to the speaker. So no matter how fast we get our computers to be, and no matter how efficient we get our analog to digital converters to be, there will always be some latency. Why? Well, one, you have at least the amount of time that is the sample rate. Then you have to think about how that is multiplied, because you have the delay on entry into the system and delay on exits from the system. Then there's the amount of time that it takes to to do all of the conversion within the analog to digital and digital to analog. That is always going to take time. To get the sound from the DAC to the computer and into the software you're using, into the DAW, also is going to take time. These days, we are with the power of the computers that we have and the efficiency of the digital analog to digital conversion and all that, we are able to get latency down to very low. So we can get down to 5 milliseconds, which is right about the threshold of where a human can tell whether there's a delay or not. Of course, the more CPU load you're putting on your computer, the more that the computer is going to have a tough time with that, and it might fail if you're really trying to push the latency down. So with a lot of DAWs, if you have a bunch of effects going on and you have a bunch of tracks, all of that information needs to get processed. So if you're trying to get a super short latency, the program might start having some failures. Now, this, for when we're talking about the DAW, how it's typically being used, actually isn't such a big deal. Because what DAW can, so for instance, imagine that you are recording, you're recording a guitar track and you want to play along with a drummer that's already been recorded. So you can see how latency could be a concern, because if there is a 5 millisecond gap between when the sound is going into the computer and when it's coming out, that means there's going to be a gap between when you're playing and when and if you're like tracking, there's going to be a gap between when you play and what is going to get written into the DAW for the guitar track, if that makes sense, right? So if you're playing along in real time, meaning you're listening to the drums going, and then you play that chord, if there is latency, then you will play, but there will be a slight delay between when you play and when the computer records that sound, and then it should be off, right? Because you're playing to what you hear. Fortunately, there's an easy way to fix this. So what the digital audio workstation can do is say, "Oh, I have a particular latency. So basically, what I'm going to do is I'm going to when you press record, I will give you that exact delay before I start giving you the playback. And that way, we'll all be in sync." So in a way, it's like the digital audio workstation knows how to think a couple milliseconds faster. And so it's always maybe like a couple milliseconds ahead to make sure that everything is syncing up. This isn't so easy if you're trying to use computers to do live music, of course. Okay, so that's one way to think about the issues that are involved in synchronizing the digital audio workstation with yourself if you're recording, say. The digital audio workstation, like I mentioned earlier, is also something that allows us to connect and synchronize with other digital instruments and devices. And some of those would be, for instance, as I list them here, you've got, like, you could have various controllers. So if you have a digital mixer, there's going to be a mic preamp on that mixer. So whatever you're plugging your mic into is going to be is going to be synchronized with your digital audio workstation. You could also have effects that are connected to it. And all of these elements in your system need to be as synchronized as possible, like on the same, they need to be on exactly the same. They need to know exactly where they are in time in relation to one another, so that it works. So that if you were to say, okay, I'm going to put I'm going to change the level on this track, you want it to be synchronized with all of the elements in the system. So the way that this works in digital audio is what is called a word clock. And what a word clock is once you set up your system, it's usually going to be the computer that has the digital audio workstation on it will be responsible for sending out what we call word clock, which is really just a tick that happens at every sample. So that's why we call it sample accurate master clock that holds all audio components in sync. So what's happening is the computer, the computer that the digital audio workstation is using, or really the sound card, is going to be sending out a click every sample. So say you're in 44.1. It's going to be sending out a tick that happens 44,100 times per second. That is the master. That is the master device, your computer. All of the other devices in your system are going to be what we call slaved to it. So that means that they are listening for that tick. And they are letting the master sort of let them know where they are. All it is a tick. It's just now, only much, much faster. And this keeps them all in sync with one another. Why is this important? Well, sometimes when you set up a system, you can have, for instance, one device is expecting a different word clock than what the master device is doing. So say you have set up a mixer and you've told it, oh, I'm going to be in a sample rate of 44,100. Then you start up your digital audio workstation and you start it up in 96,000 samples per second. You will actually hear this weird clicking sound. So, and the reason for that is that your mixer is expecting a different type of word clock, is expecting a different speed of the word clock than what is being sent out from your computer. Now, this becomes even, I think the importance of word clock can be made even more clear if we talk about putting audio and video together. So, video has its own version of word clock. In other words, a way to synchronize multiple devices in time. And what in the realm of film and video, what they don't use word clock, they use SMPTE timecode. So SMPTE standing for the Society of Motion Pictures and Television Engineers. And what SMPTE timecode is it is a way of keeping track of the frames. So SMPTE is usually in 24 frames per second. That's how fast film traditionally goes. So here, I don't know how familiar this image is to some of you. I mean, definitely for those of you who grew up with television, with a lot of television, this image should be really familiar to you. So down in the bottom here, we have this readout of numbers, and this is actually SMPTE timecode. So if you see this at the beginning of something that's usually recorded to videotape or something like that, that's what it is. It's SMPTE timecode. And what these numbers mean, what they indicate, is 0 hours, 1 minute, 22 seconds, and frame number 24. So 24 frames per second. So we're just about ready to flip over to 1 minute and 23 seconds. Now, let's compare that. Let's compare SMPTE with word clock. The main there are a couple of differences here. Word clock, remember, is just a tick. Word clock does not care about what minute we're in, what second we're in. All it cares about is just ticking at sample rate. So that's one significant difference. So it's less information. One tick of the clock is less information. The other significant difference is the speed. So SMPTE is 24 times per second, at least. Word clock is at least 44,100 times per second. The fastest SMPTE ever gets, this is like if you're making a super fancy movie like James Cameron or something, is 48 frames per second. The fastest that sample rate's going to be is going to be over, 96,000, even more. So word clock is so much more precise. We're comparing 24 notches on a ruler to 44,100 notches on a ruler. Now, this is really important because if you ever start trying to synchronize video, an already recorded video, with already recorded audio, say that you go and you record a video with one device, and that's using SMPTE, and then you're recording audio with another device, and that's using word clock. And you record them at the same exact time, and then you get home and you put them together, right? What you're going to often find is what we call drift. So at first, the audio and the video will sync up perfectly, but over time, they'll start to drift from one another. The audio and the video will seem out of sync, and you'll be like, wait, did I not synchronize it correctly in the beginning? You'll go back and you're like, no, I did. It's like getting off. And the reason is that audio is just much more precise when it comes to dealing with time than video is. So as time is going on, because you have these notches of 24 versus 44,100, you can see that over time, because the fine-toothed comb of word clock is so much more precise, as those seconds add up, as you get up to like 4 minutes or something, it's going to start to be a little bit off. So there are all sorts of ways that you can adjust for this. So, for instance, there are ways that you can have your camera be slaved to the word clock on an audio device, or you can just be kind of recording audio in smaller fragments so that the drift doesn't really become apparent. The real point here is that word clock matters a lot because this synchronization is what this is all about. And if you can't get multiple devices to synchronize really, really precisely, then you have big problems with just kind of doing really simple projects. So yeah, for example, here, say this is how you would be adding audio to video. So we have multiple. Here we're looking, this happens to be in Pro Tools, we're looking at a digital audio workstation where video is being dropped in, and they're adding the soundtrack underneath. So here we can see these different shots, 3 different shots, one waveform underneath. And as these shots are changing, we're seeing, as these shots are changing, we have this constant sound underneath. Over here, we have the SMPTE readout of the video as this video is being edited, but this SMPTE readout is slaved to the word clock on the computer. Okay, so this is like a good intro into the digital audio workstation. It is about integrating things. It does this by letting you have this sort of control, centralized control. And importantly, it does this via word clock and other types of codes, of ways of communicating between software and devices. Okay, so let's move over. Like, what I want to do now that I've given you this whole introduction on the DAW, let's actually open up Studio One, the example of our DAW, and I'll tell you a couple of things about it, and give you some instructions on some things I want you to try in between now and when we meet next. Okay, so I'm going to start by opening up Studio One. So let's see. And as it's opening, you'll see all of these different things that are loading. Now, this is one way that we can really demonstrate the what's going on with the anatomy of the computer. So I open up the application. It needs to load all of these different files and all of these different packages from the hard drive onto the onto RAM that the CPU can manipulate. So when we see we see that long pause and we see all these different things loading every time we open it up, that's what's going on. There are a whole bunch of different packages and scripts that need to be loaded in order for your DAW to do all of the things that it needs to do. So here we are in the screen that opens up right when we open up the program. Over here, obviously, I have my recent files. Here, this is sort of an important thing to keep track of. For you all, if really you're only working just on one computer, this won't give you a lot of troubles, but it's important to understand what's going on with your audio devices. So this is what the window looks like on a Mac. It looks slightly different on a Windows machine, but it's all pretty much the same. So here, when I open up this preferences window, this allows me to make some decisions about several things. So, this is pretty much like straightforward, like what language do I want to be in? What, like we don't really need to mess with this. Here I can set up where all of my projects are going to be saved to. This is important. So here I have all my projects are going to be saved to my documents folder and then in another folder called Studio One. So it probably will set this up in a way for you that makes sense, but this is something to check out because as you'll find, once you start working with audio, organizing all of your files becomes actually kind of complicated. I'll come back to audio setup in a second. Here we have external devices, just like I was saying. One of the things that the DAW is all about is integrating all sorts of devices externally into it and communicating and being in control of them simultaneously. So when we start dealing with keyboards and MIDI, we'll learn a lot more about this. Here's my audio setup. And what the audio setup allows me to do is control where my input signal is coming from. So, for instance, right now, as I'm speaking, the microphone that I'm speaking into is coming into this external digital to audio converter, this external DAC, the Scarlett 2i4 USB. I'm going to switch that. Oh, it doesn't allow me to. What just happened? Huh. Well, I won't switch over to that. And the reason I don't want to switch it over to that is because as I'm recording, I'm using another application to record this lecture. And in order for that application to hear the output of Studio One, it needs to be set up for multi-output device. Now, I'm not going to go into all of this for you all right now, like how to set this up. It's kind of complicated. But the point being that there are connections, virtual connections that are happening behind the scenes. So I've set this up so that I can hear back, that I can put sound into Studio One, but also that Studio One will play into the application that is recording this lecture so that you all can hear it. So all these things are being synchronized in a kind of complicated way. But this is why knowing what the output and input of your studio of a DAW is doing, because it depends on how you mean to use the DAW, right? So, for instance, right now because my main purpose is to record this lecture, I'm letting the video recording software really be in more control of the audio in a sense than my DAW. Okay. I can change the sample rate. I can change, I can affect the latency by changing the block size. For instance, if I reduce the block size, it reduces the latency. But if I reduce the block size, there is a higher chance that I'm going to have little audio failures because the CPU just won't be able to keep up. Keeping it at around 512 is fine for our purposes. Okay, so I'm going to start a new song just by clicking. I could either click new song here, or I can click song up here. I'm going to start a new song. It's going to save to the location, to this location, documents, songs, and I'm going to call this first go. Okay. So I've created first go. Now, real quickly, let me just show you all. So I'm going to close out of here. And I'm going to open up the folder where, so Studio One just created this new Studio One file. And if I go to my documents, you get to see how badly organized all this stuff is. If I go to my documents and I go to Studio One, so it told me this is where it would be saved. And then into songs, right? So here I am in songs, and what I just created was this Studio One session, first go. If I open up this folder, okay, yeah, so there's nothing there yet. But this is where the session itself will be saved to. Once I press save, we will see it. And if I start recording into Studio One, I will see the audio files appear within this folder. Okay, so this is important because we're going to start dragging audio files into Studio One from outside of it rather than record. And you'll notice that Studio One will not make a copy of the audio file that I drag in this place. It'll just keep a record that, oh, I know where to find this audio file. Okay, so back over, wrong window, back over to Studio One. There we go. Okay. So to start off, let's create a track. I'm going to add one mono track. And I'm going to call this track Hamlet, and you'll see why in a second. Okay, now I have created one mono track, and this is a track where I want to import a audio file into it so that I can play around with the waveform. There are two ways to do this. One, I could drag an audio file in here, drag and drop it. So the audio file I'm looking for is this Hamlet1.wave. I've put this on this particular wave audio file on Blackboard if you guys want to mess around with it. So I can drag and drop, and this waveform has now been inserted. I can also, let's see, I can also import, I can do this by going import file, and then we should, so Hamlet. So those are two ways to bring an audio file into Studio One and insert them into a track. You'll notice that if I drag this over, So these are the two copies. When I imported, what happened was it took the same file from my downloads folder and just put it on top of the one that I dragged in. But they're the same exact audio file, the same exact information. Okay, so now that I've done this, I have these these waveforms in Studio One, and I can listen back to them. So let's just go here.
To sleep, perchance to dream, aye, there's the rub. For in that sleep, a death what dreams may come when we have shuffled off this mortal coil. Must give us pause. There's the respect that makes calamity of so long life. For who would bear the whips and scorns of time, the oppressor's wrong?
Okay, cool. So yeah, you can see now that it's from Hamlet's famous "To Be or Not to Be" speech, and I'm hearing the sound come back to me, and you should be hearing it coming out of the video now. So let's just look at navigating the timeline here so that you can get a feel for manipulating a waveform. Right now, I'm just going to be focused on navigating the timeline, the time ruler up here, talking about that a little bit. Next week, we're going to dig much more into different types of splices and fades and all of that. I just want to set you up with a way to confidently start experimenting with taking different parts of a waveform out and putting them in different orders and repeating them and all of that. So, so here I'm going to zoom in a little. Let's see. I'm going to zoom in here. Now, so I can, let me zoom in a little bit more. As I am sort of moving as I'm moving this crosshair over the waveform, you can see that even though I'm trying to move it smoothly, it's just kind of skipping from one notch to the next. And that's because it is set up automatically to snap to the grid. And what that means is my tape head, when I press play, where it'll start playing from, or if I were to select something from the waveform, where it would begin and end, is automatically being shifted from one of these ruler notches to another. So if let me just show you so you can get a sense here. So
to be.
Okay, so wherever that, like when I press play,
to be,
it's going to start wherever the tape head is.
Or not to be.
Now, the reason that the tape head is sort of shifting the way that it is, and the reason it's set up this way is, well, think about, you're trying to put different sounds together and keep them in sync as far as rhythm, and what this allows you to do is precisely keep them synchronized on a grid. So when I say a grid, we can see here the readout here is not in minutes and seconds, right? This is not like SMPTE timecode up top. This is in bars and beats. So we see 1, 1.2, 1.3, 1.4, 2, 2.2, 2.3, 2.4. So what this is telling us is 1, 2, 3, 4, 2, 2, 3, 4, 3, 2, 3, 4, right? So let me just, I'll rewind it to the beginning.
To be. on,
So let me see if I can count along. So it'll be like, so 1, 2, 3,
to
4,
be
2, 2, 3, 4.
on,
So, and so that means like if I start to cut some of these, if I let's say I want to splice out to B, and I want it to be, and I want to just hear that to be, I can copy and paste it and keep it on that grid, and I don't have to worry about like slightly shifting it around to keep that rhythm going. However, if I'm trying to splice out of a waveform that is not, like, he wasn't reading this on a grid. He was just kind of reading this naturally. And if I want to get just this waveform, like right where he starts saying "tuh," right? So if I were to start,
to be
there's a little bit of a pause before he actually says that T. And if I want to splice in right there, it's not letting me. So once I zoom in closer, it allows for me to do what they call adaptive snapping. So you can see as I'm moving back, and this is after I zoomed in, past about halfway on that little zoom fader down here. And when I get, maybe 20% closer to the notch, it kind of notches over, but it allows me to kind of splice in wherever I want to in between. So I could select this and really get my to be. Again, however, maybe I don't want that at all. Maybe even this adaptive thing is annoying me. I can change how the tape head is being snapped to the grid from underneath this snap window. So right now it's adaptive, which once I'm zoomed in enough, it kind of figures it out for me. I turned off snap to grid, and now you'll see it just smoothly. It doesn't snap no matter where I go. Okay. So now I can select this, and there are a couple of things I can do. Before I start cutting and pasting, I want to talk about looping. So, and the reason is because looping can be really useful when you're trying to figure out what you want to splice out. So, right now, when I press play,
to be
the tape head just goes. It just goes right along with the clock. Now, if I wanted to just loop that one little section that I made, if I go to loop section, and I make sure to turn on the loop, activate the loop mode down here, and then I'm going to rewind. You'll notice that once the tape head gets into that looped region, it'll just start looping.
To be.
Now, why this is useful is, like, let's say I want to get the perfect little splice of this to be, and I'm trying to make sure that I get it just at the very beginning of when he says "tuh." So now I can kind of listen here.
To be.
And I can adjust the loop. So, for instance,
be,
okay, so and that allows me to sort of adjust what I'm listening to, and now I can know, like, for instance, if I wanted to I'm just going to press copy. I've now copied just this one section of the to be or not to be speech, and I could, for instance, add a new track, a mono track. This will be, maybe I'm just going to call this 2B. And I'm going to select that track. And if I press paste, here we have this one. We have what I just copied. It's the exact copy of what's above, but now I don't have the whole waveform. It's just this one thing, right? And I could, for instance, now I could. Let's say that I'm going to just keep the Hamlet waveform that I want to be sampling from, that I want to be selecting from up top. I can mute it. And now we are going to just hear. We are going to just hear the what I copied down to the second track. Whoops.
To be.
So just so you can hear the mute come on and off, I will loop. So
to be.
That's with the top track muted and the bottom track on. Here's with them both.
To be.
So now that I've kind of selected out this one bit of this to be or not to be speech, just to kind of give you a little bit of inspiration, maybe. Let's just take out another part of. Let's find another part of the speech.
'Tis a consummation devoutly to be wished.
Okay, I'm just going to take out a couple of other little pieces, and then we're going to turn this into a new semantic meaning. So what I'm doing as I go through, I'm just kind of going through looking for different wave shapes.
Thus, conscience.
Different wave shapes, and that seem like they might fit together well with my to be. So, and I'm just copying from one track and pasting them to another. And I'm just going to kind of pull down 5 little snippets, I think, and
enterprises of great pith and moment.
And what I'll be able to do then is to, out of the Hamlet to be or not to be speech, I can create a new semantic, a new semantic information, new semantic meaning. So let's just do one more. Maybe from.
Or to take arms against the sea of troubles.
Right.
Arms against the sea of troubles.
Now, if I zoom out to see all of this, I can see now I've got these various snippets that I pulled from the overall speech, and now I can put this all into whatever order I want. So and really, like I said, I was just kind of going through at random, as you could see. And I'm going to do this, zoom in, move this over like so, and maybe this over here. And without having to really think very much about lining all of these up, I can now create a new loop around this new semantic information, this new semantic meaning, and I can rewind it, and let's see what we've got.
To be the sea of troubles. To be.
Oh, let's try this one more time. I forgot to mute the top one. Let's go back. Here, just the bottom track, the to be track.
To be the sea of troubles. Thus conscience, pith and moment, to be the sea of troubles. Thus conscience, pith and moment, to be the sea of troubles.
Okay, so you get the point. I mean, and this is just with the famous speech. I mean, you could be splicing out musical content. You could be splicing out soundscape content and reordering them. So for now, just do that. Like, see if you can get. I've uploaded some audio that you could use if you don't want to kind of search around yourself, but maybe you can find some audio that you'd like to start copying and pasting around. Set up a couple of tracks, start moving, get familiar with muting different tracks, get familiar with looping things and navigating using the timeline, turning grid on, turning grid off, and copying and pasting out smaller portions of the waveform to create new sequences and new meanings. We'll meet and talk about all of that, and next time we'll actually dig into some actual techniques, various techniques of splicing, fading, and starting to talk about musical applications of what I just did, not just this kind of like semantic reordering. All right, have a wonderful weekend. I look forward to seeing you all next week, and stay safe, stay happy, stay healthy. Okay. Let's see. Goodbye.